missed that. We're locating points and midpoints. Midpoint is a point found between 2 points. They are exactly in the middle or equidistant from the midpoints. And so in order to find the point that is exactly in the middle, we want to find the average of the x values and the average of the y values. So if I add my starting point and my ending point, those x values together, divide by 2, that will give me the x value of the midpoint. And then if I add the starting and the end point y values together and divide by 2, that will give me the end y value of the midpoint, or the midpoint of the y value. So let's try an example so we can just see how it works. All right, so if I asked you to find the midpoint of 3, -2, and 7, 4. What you want to do is, first, I think it's helpful to recognize what your x sub 1, your y sub 1 are, and your x sub 2 and your y sub 2. And you just take those values and find the average. So let's start off with our 3 and our 7. Well, I'm going to go ahead and visualize what's going on. And we have 1, 2, 3, 1, 2. So I have 3, -2 there. And 7, 4 right there. So here's my first point. There's my second point. I want to find what point is in between them. So first, let's find that x value. So the midpoint of the x value will be adding my x values together and dividing by 2. So the first x value is 3. The second x value is 7. 3 plus 7 is 10. Divided by 2. So I'm getting that the midpoint between these 2 points is going to have an x value over here at 1, 2, 3, 4, over here at 5. But what is its y value? Now the y value of the midpoint, I'm going to add the y values together, divide by 2, because again, we're finding the average. And I get 2 over 2, which is 1. So that means that the y value of my midpoint is over here at 1. So together, that coordinate point is found at 5, 1. So that is the midpoint. So you take the average of the x values, average of the y values, and together they form the midpoint. Let's bring back a skill from yesterday. What if we wanted to find the distance between 3, -2 and 7, 4? So if I want to find the distance between these 2 points, I would need to use that distance formula. Now, I did tell you that I never expect you to memorize it, so I'm going to go ahead and give it to you now. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we just went over the midpoint, but why don't you go ahead and see how your distance formula skills are, and between those same 2 points, go ahead and find the distance between them. I'm going to see if anyone in person. Yes.
Can I show you something on the board?
Sure. What do you want to show me?
It's a trick. This is how I like to write things. This is how society makes me write things, and that makes me feel like this.
Fair enough.
I just learned that trick by myself. I
Well,
like
well
to go
done.
backwards and society makes me go forwards, and that makes me feel angry.
Very nice. I didn't know that you could write on the smartboard
Oh yeah,
from your side.
oh yeah, I like to go backwards and forwards. Like
very
writing.
cool.
I can write mirror image and forward.
That's pretty cool. All right, let's go ahead and try that
Wait, you're
distance
recording?
formula.
I'm sorry.
That's okay. And just because I forgot to resume the recording, that was the answer to the previous problem. So you have it. All right, so distance formula of these two. So again, I'm going to label just so I don't lose track. Be careful of those double negatives. And that's what gives me the square root of 90, which I know 90 is between 81 and 100. It's a little bit closer to 81 than it is 100, so I'm going to say it's about 9.4. Unnecessary step, you can just plug it into your calculator, but sometimes I like to kind of quantify what the radicals are approximately equal to. For the midpoint, find the average of the x values, find the average of the y values, and then we're done. So let's add the x values together. 1 plus 4 over 2 is equal to 5 halves, which is also equivalent to 2.5. Either one is fine. Negative 4 plus 5 over 2 is equal to 1 over 2, which is equal to 0.5. So your midpoint is either going to be, you can have as 5 halves, 1 half, or you like the decimals, you could do 2.5, 0.5. Or you can do a mix of them if you want. I don't really care. Either way is good for me. So that is the distance between 2 points and the midpoint of 2 points. Now, before we get to that worksheet, do we have any questions with using the distance formula or using our midpoint formula? All right, then. So let's take a look at this worksheet. So what this activity is doing, originally you'd be able to work in groups, but obviously pandemic throws a little wrench in that plan. You are doing this individually, but we'll kind of be working together as a group, because what I want to do is just kind of read through a problem or two, discuss what strategy we want to use to solve it, and then I'll let you go ahead and try that problem. We'll try to get as far as we can, and whatever we don't finish, we can do for homework. So the way that this amusement park is broken down is it's broken down into quadrants. In quadrant 1 here, we have the carnival park. So everything you'd expect from a carnival ride is up here in the first quadrant. In the second quadrant is their water park quadrant. So everything dealing with water on a nice hot day, you'd want to go up to quadrant 2. Down here in quadrant 3, unfortunately, it's under construction. This is the roller coaster park. They had a person that fell out due to safety harness reasons. They had to kind of rebuild the roller coasters. We'll get to that problem later on. And then quadrant 4 is the carnival games. That's where they really like to take your money, and you can play carnival games down here. So all these questions are dealing with the coordinate points that you can see going on this Wild Wonders amusement park. So starting off, the entrance is over here at -8, 0. The exit is over here at 8, 0. Now, what might be helpful is to recognize that these are counting by units of 2. So 2, 4, 6, 8, not 1, 2, 3, 4. And it might also be helpful to write the coordinate points above these locations. So if we're using, let's say, the Ferris wheel, we'd want to recognize that maybe this point is at somewhere it looks like 5, maybe 7. So if you're using the Ferris wheel, it's at 5, 7, or 5, even 6.5 if you want to get technical. So that could be a helpful strategy, that if you're using the Ferris wheel, to write down the coordinate point that is associated with that location. Now, here are how the questions are going to work. Number one is saying that we have a food stand at the origin, which is pretty smart for an amusement park. No matter where you go, you're as close to the food stand as possible. And so right here at 0, 0, we have our food stand. Now, this first question is asking, how far is the exit from the food stand? So you forgot your water bottle and you don't want to pay $10 for a water bottle. So you're going to run out to your car, get your water, and come back in. So starting at 0, 0, how far is the exit from the food stand? So we want to go to the exit, and we want to know how far away are we from this exit. Now, since they're saying how far, that means we want to use the distance formula. Now, I said yesterday, finding the distance of horizontal and vertical segments are easier because there's an intuitive way to do it and there's a mathematical way to do it. But this is also a good opportunity to practice the distance formula. Since you may already know the answer, you'll know if you're right or not. Now, number 2 says you decide to start your day at the darts game after getting some food. How far is the darts game from the food stand? So the next question isn't as intuitive. You can't just count. And you're going from 0, 0 to 2, -6. Once again, you're going the distance to the darts game. So you want to use the distance formula from 0, 0 to 2, -6. So go ahead and try number 1 and number 2. I'll give you some time. See if anyone in person needs any help. Obviously, if you guys need any help, let me know. And I will go over the answers, show you the work, and then we can move on to 3 and 4. So go ahead and try 1 and 2 and see how it goes. All right, so with number 1 and number 2, number 1, you're finding the distance from 0, 0 to 8, 0. And so, as I said, you could have probably done this a little intuitively, that if you're going from 0 to 8, it's 8 units. But just to practice the distance formula, I made 0, 0 my first point, 8, 0 being my second. And so when I plugged in those values, I got 8 squared plus, this cancels out. So 8 squared is 64. The square root of 64 is 8. Number 2, you are going from 0, 0 to 2, negative 6. And so again, label x1, y1, x2, y2, start plugging them in. Here you'll notice that with my negative 6 squared, I kept the negative 6 in parentheses, because if you type it into your calculator, and if you did negative 6 squared, you might get negative 36 back, because the calculator doesn't understand that you want negative 6 in parentheses squared. So if you do negative 6 in parentheses squared, that will give you positive 36, because now the calculator knows that the negative is attached to the number. Otherwise, it just plays dumb and thinks that the negative isn't attached. So 2 squared plus 6 squared is 4 plus 36, which is 40. Square root of 40 is about 6.3. So the distance from the food stand to darts is about 6.3 units. All right, so for the next 2, you heard the milk jug game is a blast. How far is the milk jug game from the darts game? So you were at darts at 2, negative 6. You're now going to the milk jug game, which is located at 8, negative 4. So again, since you're finding the distance from darts to the milk jug game, that would also be the distance formula. Number 4 is saying you decide to go to the lazy pool next. Your friend said that the halfway mark to rest, because it's a long ways away, is at 2, 0. Is your friend correct? Now, what's happening with number 4 is you're going from the milk jug game to the lazy pool. Your friend right here is exactly in the middle of the milk jug and the lazy pool. What you want to do is double check her logic and figure out where is the midpoint of the milk jug and the lazy pool, and is it at 2, 0? Or could it be somewhere else? So for number 3, you're using the distance formula, and for number 4, you want to use the midpoint. 3, you should have gotten the answer of square root of 40. For number 3, it should have been the square root of 40, just like number 2, or about 6.3 units. And for number 4, you should have found that the midpoint was at 2, negative 1 instead of at 2, 0. So your friend was not correct. Awesome. What was that? Yes, the friend was wrong. So I'm going from the darts game to the milk jug game, which is located at 8, negative 4. And again, we want to know how far it is, so we're going to use the distance formula. So 8 minus 2 squared plus negative 4 minus a negative 6 squared, square root of that. So 6 squared plus 2 squared is going to give us the square root of 40. Because again, these double negatives turn addition, which that's what gave us the 2. Now for number 4, they want to know, is 2, 0 really the middle between the lazy pool and milk jug game where we're coming from? And so we're going from 8, negative 4, and we're traveling to the lazy pool. The lazy pool was located at negative 4, 2. So what is the midpoint of these 2 values? So the answer is going to be a coordinate point. To find the x value, I'm going to add the x's together and divide by 2. So I'm finding the average. So 8 plus negative 4 divided by 2 is 4 divided by 2, which is 2. To find the y value, I'm going to add the y values together and divide by 2. So -4 plus 2 divided by 2 is -2 divided by 2, which is -1. So unfortunately, your friend was not correct with 2, 0 being the midpoint. 2, -1 should have been the midpoint. Any questions with number 3 or number 4? All right. Then the last 2 problems, I don't think we'll have enough time to go over them, so I want to at least get you started on them. So if you wanted to complete it now, you could. And if not, you can kind of do it on your own time. That is number 5. The park plans on building a roller coaster called the Intimidator. And that will be halfway between the entrance and the darts game. Where will it be built? So the entrance is at -8, the darts game is at 2, -6. The Intimidator is going to be somewhere between the entrance and the darts game. So your answer should be somewhere around here, because if I were to draw a line straight through from the darts to the entrance, somewhere in the middle is going to be in the roller coaster park. So you want to find the midpoint between the entrance and the darts game, and that coordinate point is where the Intimidator will be built. Now, number 6, I think, is the most challenging problem on the worksheet. It says now plot the Intimidator. So once you know where the Intimidator is supposed to be, you go ahead and plot that point. And there is a restroom at -2, 0, which is going to be halfway between the new Intimidator ride and a new carnival ride that'll be called the Spider. So where will the Spider be built? Plot and label the Spider ride and explain what you did. So showing your math is enough of an explanation. So again, you first have to figure out where the Intimidator will be. And then you have a restroom at -2, 0. And then the carnival ride is going to be built in the carnival park. So wherever this is going to be, it's going to go halfway to the bathroom because you've just been intimidated and now you need to use the bathroom. And then you are going to be going on to the carnival park where you are going to be riding the Spider. So those are the last 2 problems. For number 5, you want to use the midpoint formula. For number 6, you're going to be using maybe the midpoint formula, maybe the distance formula, maybe both. You are open to your own strategies. We get to use some constructive thinking and kind of imagine a solution to this problem. So I'm going to leave you at that. We have about 10 minutes left in class, which that's the time that's supposed to kind of be for your time to work on stuff. So I'm going to go ahead and